Good morning, good afternoon, good evening. Welcome to Groundbreakers. And today we're very lucky to have Mr. Rodrigo and Mr. Shiv Mohan with us today. I met them recently in Dubai, and both of them have extensive experience in the industry of construction, civil engineering. And Rodrigo has been now he's at WSP, so he has a lot of experience and he'll be bringing in insights from the consulting perspective. And Shiv Mohan is now at L&T, and he's going to be bringing in insights from the system integration perspective. So we have EPC, monitoring tech, and consulting all in the same room today. So I'm very excited to see the insights that we can spin out of this conversation and share with the industry. So thank you so much for being here today. Perfect. So
Thank you, Ritik, for having us.
thank you. Thank you. So let's start. Um, So the core theme of today's podcast is that monitoring systems today used across mega projects, especially in the city of Dubai. For example, the ones Abil Tower, Dubai Blue Line, Creek area, the whole marina. There's so much monitoring happen. It never fails because of the bad technology. There's no issue in collecting data today. Today, we can collect data from satellites. We can put a bunch of boreholes, collect data. We can have various sensors. We can have SCADA systems. Collecting data is easy. Collecting the right data with the right specs is still challenging, where that's where Rodrigo comes in to help design the specs of the project to make sure you're collecting the right data. But the technology to collect the data is not the challenge. The challenge is that the specifications today aren't designed to support decisions. And today, even if we integrate the data, the analysis and the tools that are built post the integration aren't designed to be able to give the engineers the ability to take decisions. And what I mean by that is that you have beautiful dashboards, beautiful reports, but you still have to spend hours with someone in a room to make those decisions. So that's the whole concept. So before I dive deeper, Shiv Mohan, Rodrigo, do you want to take a take at it? Because you have a lot more experience than me. What do you feel about this in general based on your experience? Let's go one by one.
Rodrigo, you would like to go, or should I go?
Okay. No, you go. I was being polite. Go ahead.
So, Ritik, is very good question that there is no dearth of data. There are a lot of the technology. It is not a technology problem that data is not available. Data is available, but yes, the problem comes, as you told, that the dashboards are there, the sensors are there, the alerts are there, but the problem comes when we do not specify the decision making. And the reason is this, that when we define the full monitoring system, it is defined that, okay, what sensors will be used, what we will measure, but it is very much important that it should be also defined that what decision it will support, whatever measurement we are doing, what decision it is going to support. So it also, what happened that we play in the silo that, okay, one discipline define their what data we need to collect, what what are the accuracy should be of from that particular sensors and all, but we never integration is assumed but never specified. So what happened that we are not able to talk in coherency. So when we are not all the system, all the discipline, the data is coming, but the meaningful decision is not able to be taken. So the requirement is fragmented across the vendors, across the discipline. Also, like threshold are defined. Sometimes it is defined, okay, this will be the red category, this will be the amber, this will be the yellow. But what comes after that? What decision need to be taken? And who will take that decision? So it is very much defined not only the data point of view, how that data processing will happen, how the alert will be generated, and then what decision need to become. So that's how we are facing the problem. And it really impacts the cost overrun, schedule overrun. So that's how we are facing the problem. Rodrigo, for you.
Thanks. And I think for me, it's more or less along the lines of what you're saying. And you're on the contractor side, I'm on the consultant. I think
Yeah.
then the name of this podcast is somewhat provocative because um, we're saying there's no issue with monitoring failing, but there is something to support decision intelligence. And I think that's precisely the diagnostic that we all can make. Um, like building on top of what Shiv was saying, from the consultant point of view, it's the same. It is interesting that it's the same issue. You would think that in a planning stage, where we tend to work more in a planning stage rather than a construction, but it's the same issue. It's not the monitoring, but are we supporting any decision workflow? So most likely in the design, it's all about being efficient with the design. But for example, once you are building from the contractor side, it's about probably cost saving. It's about probably planning, program savings. But in general, it's very difficult to integrate the end product of the monitoring. And I think that's why uh, people that are really informed about what monitoring capabilities we have right now, they really like to go with that. But the majority of the market, I would say, we need to do a lot of work to convince them why monitoring it's good for their project. So I think what we're discussing here, it really addresses the gap that from the monitoring to decision intelligence. Totally.
True, and I agree with both your perspectives because one is the cost, second is the lack of information, and that's why to diagnose this also I feel we also box monitoring in projects, very geotechnical, structural, environmental. Now that's coming up, but we also don't look at the operational side of the monitoring. Like we were talking up with Shiv Mohan, I think in early March or end Feb before the war started. And this why we were discussing that how do you integrate the whole framework into something where you also have the live operations data post the project. But before we dive into that, Rodrigo, specifically for you, where do you see the biggest breakdown today and how monitoring is specified how versus how you feel it should be to support decisions? Where do you see the biggest gap?
Great questions. I think part of that is we're figuring things out as consultants, but
Mhm.
another part of it is value added. So I think monitoring is there to add value. Like we've been saying, there is no issue with the data collection. We have every time more capable sensors, IoT devices, AI. That's all fair enough and good to go, and then growing and expanding. I think the difficult is to find the value. So the main playground essentially is us trying to identify as an engineer what are the real needs of monitoring, and that is again tied to the title of this podcast, what decision that monitoring will support. So at any point in time during the engineering design, if we are able to identify what the real need is, then I think we have chances to deploy good monitoring systems and as you say, also increasingly better and potentially starting with the design but then continuing throughout the operation. That's perfectly feasible right now at a much lower cost than 5-10 years ago.
Interesting. So you're saying that what we really need to define at the planning stage or at the specification stage is understanding what the decision need really is for the project during construction and also during operations. So Shiv Mohan, moving it to you, how do you feel we can help the consultants figure that gap and that need out of the decisions at the start of the project based on your experience? Do you think there's any
So,
connect?
so it is very important when the project start, we start with the end in the mind. So what is the
Mhm.
requirement of, because we are developing a project, we are constructing a project which is going to be used for next 30, 40, 50 years. So it is very important who will be the end user of that, who is going to be the operator of that. And we need to have a hat of the operator, have the hat of the maintainer on us when we are designing when we are planning, when we are designing the project. And nowadays, even though it is very much now become the practice now, whenever the project is started from the feasibility study stage, people are there who are looking from the operability point of view, maintainability point of view, and looking into that. Okay, in what scenario we need to run our system. So what are, if we need to take what if and why, what if scenario, that what will happen, then why we will, what is required if this situation happen. Let's say the wind, the massive sandstorm is coming in Dubai, and the speed is going very high. Then we need to say, okay, what data I should get it, and when I need to stop the system. So from that point of view, it is very important whenever the project, the V&V cycle of the project, coming
Mm-hmm.
from the EN 50126, it is very much important that your end customer is involved from day one in your team, which is ensuring that what is required at the end. So from the operation and maintenance, both the view is very much required, and that's now happening in most of the project.
That's great to hear. So we have the end user, we have everyone coming together and really understanding the actual need of the decision. So Rodrigo, coming back to you, Shiv has said that it started happening, but which parts of it do you feel we could become into a framework or a policy? Because see, today it's always project dependent in our industry. The project depends on the type of design, it depends on the asset owner, it depends on how the contract is going through. It's there's nothing that's standardized, right? Like beyond a few things. So where do you see this from your perspective?
Um, I think I could separate the what is the technical scope of any monitoring system, and I
Hmm.
think for that there are not, let's say,
Standards.
like Euro codes specific on
Hmm.
that, but there are good guidelines. There's good literature coming from Europe, from the US, and I think technical guidance there's a lot.
Yeah.
Um, and then as designing monitoring, you take what is applicable to your case. And so
Hmm.
technically speaking, I don't think there are major challenges. I Other people might disagree, but I don't think we need like a national standard of monitoring. But what we do need is to understand what the priorities of the consumers of monitoring would be.
Yeah.
I think that's a problem that, yes, I agree. There is no standard. Maybe if you look at the AI policies that are released by certain countries or
Hmm.
entities, again, there's a general framework and you can understand how to handle the data, what to do and not to do with AI, etc. But still is not communicating what do you need from the monitoring. So again,
Yeah.
that is the task of us to try to understand what the holistic system is, and it's a back and forth with the end user, with the client, with the government agency. Obviously, they're not going to have a clear picture of what exactly they want. That's unlikely. It could happen, but it's unlikely. It's usually a back and forth where you try to understand the primary need of monitoring, and then you offer, well, this is what the market can offer, that this is what can be designed, and it's a little bit of an iterative process. The main example, it's the railway industry. I think that the railway industry has benefited so much, not only during design construction, but operation, as Shiv was saying. So I think there's huge market in the monitoring the railway and any infrastructure during operations. But again, I think where we're lacking is not the technical development of standard, is to understand the needs of the different agents, and that's not necessarily on any code or any AI policy. It's directly with the interaction with the end user.
True. No, I fully agree because there's so much technical standard for everything, but the communication and also the reality, like I remember at Save the Bat, one of the lectures they said, right, like an asset is designed for 100 years, but in those 100 years, so much changes that how do you verify that you're designing for that time? That's a separate conversation, but compress that to even the 1 year of the project, so much changes during that 1 year of the project that how do you even control that uncertainty? So frameworks are very important, and that's something that is open to the industry, and I'm pretty sure we can't solve in a 45-minute podcast. But it's a very valid point you've raised, Rodrigo. And Shiv, do you have anything to add to that? Maybe we could dive a little bit specifically into your experience with railways, because I know you have a lot. And do you want to share some insights from some experiences of yours where you felt this happening at a decision level and where you felt the gaps? Oh, yeah, on mute.
Sorry, yeah. What is happening basically, as we told that it had been started previously, the project was defined, even though project team and O&M team were not talking before, but now people understand that, okay, they are coming together and talking. But it's still what happened that in the starting, a lot of wish list comes. I want this also, I want, but the exact how it will be used, it will be explored, and it is more like having have the workshop with the different teams, the frontline teams who is going to see that data, operators on the operational control room, technician on the workshop. So then we need to we do a lot of workshop that okay, we are having these sensors, what data you want? Because even though a train create like a rolling stock creator like a 6,000 7,000 event, and a lot of signals are there, but all the signals are not useful for us. So we need to
True.
okay, what we can take from is what can be useful for my for the passenger, what can be useful for the operator, what can be useful for the maintenance technician. Then we need to define, okay, maybe the 6,000 events are being created, I need maybe only 1,000, and from the 1,000 which are critical, which are category A alert, then what decision need to come from this immediate decision. Then there's a workflow is defined, then there's a instruction are defined. So that definitely that can help into defining the decision making and
True.
try to close the close the two end of the thread. Yeah, connect the two end of the thread.
That is a very valid point. And I think even in the document that we prepared and shared with you, we talked about like a 5-layer system where we
Yeah,
said measurement layer, like what is being measured, data layer, how is the data flowing, something that you mentioned today, context, what context you need, because a parameter alone is normally not enough for most applications. Decision layer, what you said, category A, category B, category C alerts. Decision triggers, maybe not alerts, but what triggers a decision. And I think the governance layer is something that we've never really spoken about, like who sees the data, who interprets it, who decides, who is accountable. And today I feel most specifications stop at layer 1 or 2 in projects, which is the measurement layer and data layer. Some go into context layer. When it comes to the specs, context is always there, but the softwares today are very, or the tools that we use to analyze the data don't really bring in that context to the level, at least from the monitoring side. Of course, when you take it into a finite element analysis modeling software, you do get a lot more context, but the basic monitoring softwares do not enable that context to that level today. Alerts are there, but alerts, again, like you said, 6,000 alerts. Which human can look at 6,000 alerts in a day today? Even with machine learning, we have to give proper rules to that model, like category A, category B, category C, and involve it with conditions to run it. So moving to the alerts part, because I think it's very, very interesting. So they're commonly defined, like you said, Shiv Mohan and Rodrigo, but decisions are not. How do we evolve thresholds to link them to decisions? For both of you, this question.
Let me answer that again from the consultant perspective.
Hmm.
I think one way to do it is, we're good at interpreting data in ground conditions as a geotech engineers,
Hmm.
but I think it's applicable to any sort of discipline that it's being benefited from monitoring. So the one an alert level should be defined. Again, it's the decision. What do you mean by alert level? So the rail moves like more than 3 millimeters, 5 millimeters, 10. Who defines that? What are the consequences? So again, there is a previous work about defining those trigger levels or alerts and what the action is, and then working backwards to see which monitoring system, which holistic plan of devices can meet those specifications. So to me, it's not only the data that we can collect, but the interpretation that we can get. So as Shiv said, that there is a lot of signals in a railway passing, and not all of them we have to be alarmed by it. So we need to be familiar with what's normal and what is not, and then focus on what is not normal, right? So
Hmm.
that is, I think, the value that even continuous monitoring can give. Nowadays, it is possible to have almost real-time continuous monitoring, again, at a reduced cost compared to 10, 20 years ago. And then we think and we see that that's going to continue being the case. Better processing times, better devices, better network connectivity, etc. So I think, again, to summarize, it's just the interpretation that we can give to the data, and
Hmm.
then working that out with the end consumer of the monitoring.
True. And I fully agree with you. And I think before Shiv, you go, I just have one thing to add that before the challenge was, like you said, the cost of the IoT or the cost of the insert. Today, that's not the challenge. Today, the challenge is the interpretation and building something that we can visualize and understand the interpretation with. And before that used to be the cost of building a massive software or a tool customized to a project. But that today with AI agents for coding, with flexible, very good data architectures is also going down.
That's
So
right.
somewhere where the consultants and technology developers merge and we used very standardized data structures with coding agents and domain specific agents that you guys build. And if you merge them together, then we can really also look at an actual technological workflow, project specific as we go in the future, or asset type specific that can be end to end very much faster than and much cheaper than it used to take before. But Shiv, go ahead with your thoughts. You can add to that or completely counter us on our thoughts.
I agree on that, and what Rodrigo says, and also Rituki told about that. Thresholds are available. And now the question is how to connect that threshold to the decisions. And that should be very, and it is not only the decision, what decision will happen after when the yellow will turn up into, if that decision is not taken, yellow will turn up into amber, and then amber will, if that decision will not taken it very quickly, it will turn up into the red. So how that escalation logic works, that also we need to connect. Also, whoever the first line, let's say the low level of the alarm, normally the site team does those handles. We also need to really define very clear the flow that okay, if this threshold comes, let's say the yellow level, then this decision need to be taken. And now the technology is available that as soon as the alarm comes, it can have the decision aid facility. It can very quickly can give the decision to the front team that okay, you need to take either you need to take do this 1 2 3. If you go on, if it moves to the next level, if the in in case of decision and action has not been taken, or maybe the severity of the situation has been increased, then the next level of the team comes and they define that okay, what is the next level of the people will do. So what is the ownership is also very much, if you will give the define the action but the ownership is not there, if the accountability will not is not there, definitely decision will not be taken. That information will be just indication, red, yellow, and sorry, amber. But if there will be accountability, there will be a ownership. Until that, it will not be successful. So it is very important to define and also give the accountability and the ownership to different decision makers in correspondence to different level of the threshold.
Hmm. That's very interesting. Rodrigo, do you have
Love it.
something to add to that?
No, I loved it because it just told my thoughts. It's exactly the ownership is key. Yeah, who will consume that monitoring, who will own it, and will own the decision. So, well said, totally.
Okay.
Yeah, and how might we design that at scale, right? Because I know, Shiv, you have a lot of experience in designing systems, and Rodrigo, you've spec hundreds of thousands of projects. How do you design that into the project? Like technologically speaking, a little bit if you want to venture into that, but also strategically or structurally framing as an SOP. What's your ideal situation?
Okay, if I will, if you allow me to answer,
Yes, go
uh,
for it.
I will go for this because it is a big question that a mammoth of data is available, and it is really sustainability of data. With what data is useful, what data is not useful, that is also very much important. What is noise, and what is real data. It is very important. So definitely for that we need to okay, and we need to give that framework. We need to give that SOP to the machine and to algorithm, and that always can happen when we take the those people into the decision making, into that going through the workshop. That okay, if you have this data, what you will do, what you want, what can help you or what cannot help you. So to keep the end user along with you in the decision making, designing that algorithm, designing that SOP, that is very much required. It is also much required that what if scenario, that if something we have never experienced, but we can do the simulation that okay, if that happen, what the situation. And a lot of simulation tools are available nowadays that okay, if
Mhm.
that data is coming, like the we do the normally into the railway, we do the simulation of the passenger flow, crowd flow, and in the condition, in the case of the fire and all these things, how the passenger will move and all. So those things is, those tools are available. And then we need to see that okay, if I am giving this information, the how it will be useful for the different layer of the decision maker. There are few are the end user, there are few are the operator, there are few are the maintenance, there are few are the owner.
Mhm.
So we need to define, and we need to define the layered approach, that okay, who is going to handle the level 1, who is going to handle level 2, who is going to handle level 3. So that is my view on how we can define the SOP.
So it's something like designing an operating system for the project where
Yes.
we have a data base, and then you have your outputs, you have your inputs, and you have your stakeholders, and then a bunch of if else categories that now you have to run live based on your simulations and your expectations, but also be able to adjust them with the reality of the project. That's
Because
interesting, Rodri.
you
Yeah.
have to take operating scenario, definitely keep into the how my overall project will or product will run at the end. Yeah.
And how do you like see that coming in projects today when you're specifying, Rodrigo? Have you ever specified this at a large scale through integrated technology, or is it still very paper SOP, communication SOP based? How have you seen this change?
Oh, I can tell you, in my case, it's definitely still old school. A spec that is disjointed. So you ask for like the ideal condition. I think from our point of view, because we're more involved in the design and planning, it's a little more difficult to find a product market fit. For example, in construction, I think the main objective is save program or save money. Let's say you can monitor an excavation, and then nowadays you can, as you excavate, you can run Plaxis models or any other software model with monitoring, do back calculations, and do some savings. You can do rock slope monitoring, and you can assess the condition of a mining slope or any slope. So that's not the issue. But what is difficult is to find that into the design. In the operation stage or the construction stage, it's a lot easier to find a scope. I think in the design, at least in my case, it might not be for all of the audience here, but we're still specifying very disjointed monitoring systems that they in an RFP could come something like we request the consultant to monitor the excavation to ensure safety, um, but there's no much scope on that. Or we want a monitoring program to optimize the design of piles, and that will combine with preliminary test piles, etc. But again, it's very focused on a task more than a
Hmm.
holistic system. And I think that's the challenge during the engineering design. That's why my team and I, what we're trying to do is, we're experts on interpreting ground conditions, doing geotech design,
Hmm.
and then we can see how we can leverage that to work more on the operations and the contractual side. So, for example, to work with people like Shiv, like in their projects, and to say, we will be your consultants in a non-traditional way by reacting very quickly to changes, to try to anticipate, I would try to reduce program, try to anticipate, better ground conditions or worse ground conditions, and then reacting earlier. So I think that's when you add value, but again, it's much more difficult to do it in the planning, designing
Hmm.
stage compared to the operations or the construction stage.
True. And do you want to dive a little bit more deeper into why, like, on the construction operation stage, it's easier today? Because I think the audience is, you've defined why it's harder on the design stage, but what are the advantages that you felt, or the places where you felt you've added a lot of value during construction operations by working in the non-traditional way?
That for me again.
Yeah, for you.
Okay.
Tricky question.
I yeah. Look, I think it depends on the scope of everybody. Every actor doing an infra or a property and buildings project, we all have different roles, right? So
Mhm.
and then there are different incentives for all of us. So the incentive for a contractor, obviously, it's to save program, to save materials, to save labor, etc. The objective for the developer is potentially also to have an accelerator program and maybe to spot cost savings early on. And so it is tricky to integrate all of that in one flow. So that's why I think naturally it's easier nowadays to figure that out during the construction stage or during the
Mhm.
operations because the asset is already near to completion, right? Whereas from the beginning, there are so many uncertainties yet that it's very difficult to craft an integrated system with monitoring. Of course, you can monitor all the parameters that you want, but again, it's less likely that someone is going to come as a designer and say, I want this system integrated specifically. But if you have an objective later on, like for example, I need to figure out the maintenance cycles of this railway embankment, that's a lot easier because you can go to that railway embankment, to that railway agency and say, nowadays we can instrument this embankment for settlement, we can monitor INSAR. Now, you can work with the client, what is the actual scope? But that's once the asset is constructed, the asset is
True.
built, or you're near completion. Uh, but again, nonetheless, I think there is a lot of work for us. Again, we're good interpreting, we're consultants, we're the engineers, so we know we're good at identifying patterns, to identifying anomalies. So like I mentioned earlier, we will be able to scrutinize what is normal pattern, normal behavior, and what is not. And so that I think it's important, whether it's a construction project or is an operations system. I think consultants still are very relevant in all of this.
For sure. And I think the real advantage today is that, or the challenge today for technology companies in our field is how do we make the lives of consultants and construction companies easier by bringing the data in a much easier way and making the interpretation a lot easier. And then maybe adding to the layer that Shiv Mohan talked about, making it into an operating system, something like a Slack community per project, like we have in our offices. Like you have like different teams on the project all working through one, like a Microsoft ecosystem. The way we use Microsoft to run our businesses, how could we build one ecosystem that we can run our projects, where of course you have maybe Microsoft Word for designers, PowerPoint that helps the construction guys, Excel helps the procurement guys, but specific tools for specific things, but all connected in the same cloud or atmosphere. I think that challenge of development is very high, and the only way we can get there is if we join hands with consultants and contractors and even some owners. Because, like you said, Rodrigo, every owner has a different issue, and every asset is different, every ground condition is different, and your expertise connect the dots and say, okay, based on XYZ, this is what you need to do. And then based on what they do, this is what you need to do. And then Shift comes in and does that, and we help provide the technology to do that. But it's always in fragments, never in an ecosystem. Yep. Shiv, do you have anything to add to what Rodrigo just said? Anything that resonates with you before I ask you your next question? You're on mute.
I agree with Rodrigo that yes, it is difficult into the planning because you have to do a lot of imagination that time that okay, how this will happen or what a lot of simulation, a lot of what if. Yes, it is difficult task, and there definitely people coming from construction, and when we come sit down on a one room and discussing these things from day one, then it may not be fully uh, make the make the things easy, but at least it can little bit uh, s- go in that direction, which can be take some shape towards defining and towards implementing.
True. That's very true. So I have one question now for both of you. This was in Shiv's brief, but I also want to ask Rodrigo that today there's a lot of automation, right? Like even Plaxis does a lot of the analysis automatically to give you an answer for which you take a decision. But and the automation is increasing and increasing and increasing and increasing. So how do you feel that for the next generation that's coming into this industry, how do you balance between automation and human judgment when it comes to engineering decisions on critical projects? What is your both your takes on this question? How do you balance automation or AI decisions versus human engineering judgment on critical projects?
Great question. I I don't think the engineering judgment will go away.
Mhm.
If that goes away, that we're lost. I don't think that's
True.
going to happen. And if someone is thinking seriously that that could happen, I think it's a big mistake. So the engineering judgment should not and will not go away. What I think the premise is we need to
Mhm.
make our our job faster, more efficient.
Exactly.
Let's say building models faster, reviewing ground conditions faster, preparing concept designs faster, things like that. So I think there's a lot of productivity priorities first. Again, I think maybe I'm speaking from the consultant point of view, but I think the balance between engineering judgment and automation, I think it's a false dilemma, I would say,
Mhm.
because the engineering judgment should not, it will not go away, but you do have to implement faster and more efficient ways to do design, which they're already happening, and that's in part what I'm doing within WSP. We were trying to really become super efficient on those repetitive tasks and to assist our engineers to do better interpretation in less time and with more data.
No, I agree with you fully, and it's actually how we don't lose that context because um, you get a lot more decisions through faster automation. But when you all were studying, like the older generation was studying, there was no chat GPT or YouTube to that level. When I was studying, there was YouTube uh, teaching us along with professors. Today, when we see kids coming up, they're learning and relying on a lot more technology to learn, which is good. But like, how do you make sure that groundwork that builds your judgment still stays is a question because if you're just relying and agreeing every single time a calculator, like calculators came in and became normal, but a chatbot or something is giving a decision, how you build that judgment through experience. That balance is a challenge that's gonna is also a dilemma. But Shiv, over to you.
So I agree with Rodrigo that engineering judgment is not going to go anywhere, even though
True.
whatever the greatest AI comes and all, because the automation role is to reduce the cognitive load,
Hmm.
while the accountability stayed with the human. So the engineering judgment will will connect with the accountability. So the automation can be helpful in like keeping the thing faster, doing the data ingestion, doing the correlation between different data, doing the pattern analysis, pattern detection. That can be done by automation, and that will be definitely we all would like to utilize the technology, and definitely we should leverage on that. But the engineering judgment comes with the accountability, and it should go with the data interpretation and decisions. That should remain with the engineering judgment. We should also define that when human need to, even though automation happening, data is coming, when the human need to intervene.
Mm-hmm.
So judgment will never go with the automation. It will remain with the engineers. It will remain with the humans.
And
We
I
really
think
hope
both
so.
I I I think it will, because to reframe my question, it's really how do we enable future engineers to take good judgments given the amount of automation coming in, and continue to have confidence in the ability to take those challenging questions. And like Shimon said, which judgments go to the automation, which judgments go to the human. That is also very important human judgment that we need to take, because, and that is again very specific to the criticality of the outcome and the speed of the
Yeah,
decision.
yeah,
Because today, a human might take 10 minutes to review a if-else statement. A machine learning algorithm can do it in 30 seconds. But is it worth that 30 seconds or 10 minutes? What is the risk? So it's a thing that'll keep coming up. But I think we're right at time. We have about 60 seconds. So thank you, Rodrigo and Shiv, for joining in online. We will post the recording as well. It was a very interesting episode of the podcast series, because I think I learned a lot from different perspectives, and we can all agree that a lot is changing. But what's not changing is the importance of human decisions and the importance of increasing the collaboration between different stakeholders of the project, and building a system where we can all be interconnected in using data, whether it's monitoring or operations, to make better decisions. And as Rodrigo said, to satisfy the needs of all the various stakeholders, which could be different or aligned. And how we do that through technology is the challenge that I give to the people who watch this online across the world, that that's how we have to start thinking. Let's bridge the gap so that we can take better decisions. So thank you so much for coming in. Hope you
Awesome. Yeah.
have a good
Thanks
day
for
and
having
stay
us.
thank
safe.
you,
Thank
thank
you.
you, thank you
Thank you,
everybody for
everybody.
listening us, and thank you for having us. Thank you.
Thank you.
It was a great session.
Thank you.
Thanks. Have a
Thank
good
you.
day. Bye-bye.
Thank you.
Thank you.